Good morning, girls. So this is about composite functions. So if you remember, we've been talking about functions as these like machines, right? So the idea is let's just say I've got a function and it's like 3x squared minus 7, right? A function is a machine that takes an x value and then returns fx, right? And so in this case, it takes the x value, it squares it, it multiplies by 3. Whoa, come on, iPad. And then it subtracts 7. Okay, so here, if I take the number 1, I square it, giving me 1, I multiply by 3, giving me 3, I subtract 7, giving minus 4. If I take the number 12, oh, here we go. So I square it, giving myself 144. I triple it, giving me 432, I think. And then I subtract 7, giving myself 425. Now, I'd like you to guess whether or not I just had a calculator with me, and there'll be a quiz question on that right now. So, what a composite function pair does is firstly you need these two functions. You need fx and you need gx. Okay. A composite function pair is something like this: f little open circle gx, and normally you'd put a bracket around the f o g, and you should read this as f of gx. And what that means is that to evaluate it, you do f of gx. So you evaluate g first, and then you evaluate f. Okay. And we'll point out now, rather than later, that normally, so this is a normally, but which I'll fill in a second, but normally that is not the same as g of fx. Right, there are certainly cases where it will be, like if the function g and f are both just the function x, in other words they do nothing, then obviously it doesn't matter which order you do it in, but otherwise it will matter. It's basically order of operations, right? If you think about, one of them is one order of operation, the other one is a different one. Like if one of them is squaring it and the other one is doubling, if you take 2, or 2 is a bad example, you take 3, square it and then double it, you get 18. If you take 3, double it, and then square it, you get 36. And they are obviously different numbers. I hope you all know that. So, let's just do an example. So let's say f is the function that takes x and returns 3x plus 1. And g is the function that takes x and returns, let's just make it simple, x squared minus 1. Okay, then we can evaluate. So we can say f of g at a value of 1, well that is f, of g of 1. G of 1, that's 1 squared minus 1, so that's 0, so that's f of 0, and that's the number 1. Alright, we could check. Let's check. So g of f of 1, so that's g of f1. f1 is 4, is that right? Yeah. And f1 is 4, so g of 4 is 15. And notice they're not the same. If they're not the same in one place, they're not the same in any place. We could also give ourselves some space. We could also evaluate just straight up like f of g. Oops. As a function. And so that would be f of the function. Sorry, something's happening, it keeps stopping recording. That'd be f of the function g, which is x squared minus 1. And remember, that means wherever we see x, we write x squared minus 1. So that gives me 3x squared minus 2. That's a 2. And I could similarly do g of f of x. So that's g of 3x plus 1. And just for the purposes of fitting it in, so that's where I see x. I write 3x plus 1. So I'll break my rule. But I'm allowed to, you're just not. So it's 9x squared plus 3x plus 1 minus 1, so that's just that. Okay, whoops. And notice they are different. Okay, which we knew from before because there was a number for which it was different. That's basically all that's in this little textbook set. But I just want to tell you one more little thing. So let's say we've got a function f, and that function is defined as f takes an x value into an fx value. Right? So basically what that means, in terms of the last video, is it takes the domain and maps it into the range. Okay, that's what functions do. They take domain values, which are the inputs, and give you back range values, which are the outputs. Now let's say I've got a second function, g. And again, g takes x values and applies the function g to them. And similarly, it takes values in the domain of g and turns them into the range of g. Now if we think about the function f of g of x, which I'll write like this as a shorthand for now, so these start with values from the domain of g, that's the x value, but then the gx is the range of g. And you can maybe start to see a problem here, which is if there are values in the range of g that are not in the domain of f, right? Something goes wrong, we take a square root of a negative, we divide by 0, something like that, then we have a problem, right? So we will have functions at times with restricted domains and restricted ranges. Restricted ranges aren't really the issue, restricted domains, that might not play nicely with this composite operation. But, of course, we'll deal with that when you come to it. Right? Essentially, if you understood everything up until this slide, you're good. Right? You're just not as smart as me. But maybe one day you'll get there. Have a lovely weekend.